get what you want. Okay, question number 11. The figure below shows an electric circuit. Okay, state Kirchhoff's first law. Okay, you can look at the circuit. We have different loops here. I'm seeing we have a power source here and we have another one on this other side. Good. Then you're being asked to state Kirchhoff's first law. Of course, whatever you're doing here or stating here, you're going to apply it. So just know you'll apply Kirchhoff's laws to solve the coming questions. So let me state this one. Okay, you can state it for us. What is Kirchhoff's second law? Yes. No, first law, sorry. Kirchhoff's first law. So the first law is about current. How does it always go? The sum of currents entering a junction or a point is the same as the sum of currents leaving the junction, leaving the same junction. The sum of currents entering a junction is the same as the sum of currents leaving the junction. So please take note of that one. If I have a current coming in, this is a junction, another one, this is a junction, this one and this one, and this one is leaving, this one is also leaving, and this is also leaving. So if this is 15 amperes and this is 10 amperes, if you're given this as 7 amperes and this one as maybe 12 amperes, what is the current here? The sum of the current entering, where is the junction? The junction is here, must be equal to the sum of the currents leaving the junction. So what do you end up with for this one? If you add this one, you get 25. If you add this side, we are supposed to have the same thing. So what is missing for us to get 25? 12 plus 7, you get what? 19. 19 plus what will give us 25? Yeah, so you will get this one as 6 amperes. Current in, current out. Okay. Part B, calculate I1 and I3. Where is I1? I1 is here. And where is I3? I3 is here. Okay, we want to get I1 and I3. At this point, look at the loops that you have and also look at the currents that you have. Because from the loops, we will apply Kirchhoff's second law. From the currents, we can form an equation using Kirchhoff's first law. Sometimes you will always use a single equation to get what you want. Sometimes you will form two equations and then solve them simultaneously or at the same time to get what you want. So in this case, we want I1 and I3. Okay, I'm seeing something. From Kirchhoff's first law, we can form an equation. Why am I doing this one? Because I've realized that if I use even this first loop, I will still have two unknowns. I have two unknowns. If I use the lower loop, I still have two unknowns. That is the current and also this one. So from what we have, there is no way we can get one of them using one equation. So one equation will come from Kirchhoff's first law. Look at these currents, I2. How is I2 moving? I2 is moving this way. I hope you can follow the red mark. When it gets here, what will happen? It will join this. How is I1 moving? I1 is moving. When it gets here, it joins this. So what does it mean? This is the junction. The currents entering this junction, we have it is I2 and I1. So if you want to get I3 in short is equals to I1 plus I2. Good. And we have I2. Therefore, I3 is equals to I1 plus, what is I2? I2 has been given as 0.6 amperes. Okay. This one is our first equation. We can just leave it there. We will use it. Now from there, I want to choose a loop, but this loop should have I1 in it and I3. So the loop that has got these two is the loop. Which loop? The loop B, C, F, A, then back to B. Yes, I hope you can see the loop. This loop, this one. Good. Kirchhoff's second law. What does it state? We only have one electromotive force here. So the sum of the electromotive forces, or these 12, should be equal to the sum of the potential differences in the circuit. The potential differences in this case will be the voltage through this, the voltage through this, and the voltage through this. What is the voltage through the 3 ohm resistor? The voltage here will be given by, remember V is equals to IR, or R times I. So I'll have 3, I multiply by I3. I don't know I3, but we want to form an equation. So the voltage through the 3 ohm resistor will be 3 times the current. Then plus the voltage through the 5 ohm resistor. What is the current going through the 5 ohm resistor? That current is the same as this one. The I1. I1 is what is running in all this. From F, immediately we get I1 moving up and I2 moving down. So here we have I1. So we have F, I1 plus the current through this is still the same I1, so plus the potential difference through the 1 ohm resistor, that is 1 times I1. So 1, let me just write 1 I1. So our 12 is equals to 3I3 plus 6I1. I can collect the like terms. This one is our second equation. So we have two equations. We want to solve them simultaneously. Which method is the best to use here? I will use substitution. In the substitution, I'm going to substitute I3. Where we have I3, I'll place this one because I3 is I1 plus 0.6. So from there, we'll end up with only one unknown, which we can get. So 3 multiplied by I3. I3 is I1 plus 0.6, then plus 6I1. I'll open the bracket, so I'll have 12 is equals to 3I1 plus, so what is 3 multiplied by 0.6? You get 1.8. So here you get 1.8, then plus 6I1. We have 6I1, we have 3I1. These are like terms. And this 1.2 is a whole number, and we have 12 here. So we can move the 1.8, sorry. We can move the 1.8 to this other side. If we move it, we'll have 12 minus the 1.8. You'll get 10.2. So here, this side we have 10.2 is equals to. Then this side we bring this together. 3I1 plus 6I1, you get 9I1. So I1 will be equal to 10.2. You divide by what? If you want to remain with I1 alone, you divide both sides by 9. Divide this side by 9. 9 will go, you'll remain with I1, then divide this side by 9 also. So 10.2 divided by 9, you get I1 as 1.13 ampere. So we have I1. Next, we are being asked to get I3. So we come and get I3. So I3 is equals to I1, which is 1.13 plus 0.6. So 1.13, we add to 0.6. So what do we end up with? We end up with I3 is equals to 1.73 amperes. So we have the two. We have I1 and we have I3. Good. We have formed two equations. Then the next one we're being asked to do what? Calculate the value of E. They want the electromotive force here. So at this point, we have I1 and we have I3. I3 is 1.73. I1 is 1.13 ampere. From here now we can use any loop, but you can always choose the easiest to you. So let me use the loop. Which loop do I use? I want to run from D. So D, C, then bring it back to F, E, back to D. So this is the loop that we're going to use. So I'll just start in this way, just my normal way, and I know we have different ways. You can always equate them to 0. So this is my electromotive force. It should be equal to the voltage or the potential difference through the 5 ohm resistor. There I'll have 5. I multiply by I2, then plus the voltage through the 3 ohm resistor, that is 3. I multiply by I3, I multiply by I3. Then finally, through the 1 ohm resistor, this one is plus 1. I multiply by, what is the current through the 1 ohm resistor? It is the same as the current through the 5 ohm. So it is I2. So 1 I2. You can bring them together. So you'll have your E being equal to 6I2. So I've added 5I2 plus 1I2, but you can still substitute them in the long way and then work them out. So my E will be equal to 6 multiplied by I2 is 0.6, then plus 3 multiplied by I3, which is 1.73. So what do you get from that one? So I'll have 6 multiplied by 0.6. Then I add to 3 multiplied by 1.73. So what do you get from that? I'm getting from here E is equals to 8.79. Yeah, 8.79. So what do you get from your side? Are you getting the same thing? It should be the same thing. 0.73. Yeah, 8.79 volts. Okay, because I want to make it short, I don't want to go beyond this one. Maybe it will give me trouble loading it. We can stop this session or end this session at this point. But please remember to always at least solve a physics question a day. Read to understand and stand out, or stand out by reading to understand. Until next time. Bye-bye.